here we have a differential equation, and I didn't write down this full question, but the question says that this differential equation is separable, and it wants you to write the answer in an implicit form, where instead of the usual c, it's using k. So let's try that. So first of all, we have we will try to factor the right side, because being separable means that you have to be able to write this right side as a product of a function of x and function of y. And for this form, the way you factor it is by factoring by grouping. So look at 42 and 49. 7 is a common factor, right? So we're going to factor the 7 out. 7 times 6 is 42, and 7 times 7 is 49. So if you factor 7 out from the first two terms, you get 7 times 6 plus 7x. And plus, for the second ones, 63 and 54. 9 times 6 is 54, and 9 times 7 is 63. So it has to be 9. You can factor 9 out. Oh, but wait, there's also the y, right? So you can factor 9y out. And the result is that 6 times 9 is 54, and 7 times 9 is 63. And then because you factored the y out, you only have x here. And then you can see that 6 plus 7x and 6 plus 7x is common, so now I can factor the 6 plus 7x out. So after factoring the 6 plus 7x out, what's remaining inside is 7 plus 9y. Okay, and now you see that we have successfully rewrote the right side as a function of y and function of x. Now let's continue on. So we now have dy over dx equal to this. And to separate this, I have to divide by 7 plus 9y, so that goes on the left side. And I multiply by dx to the right side, so all the x's are on one side and y's are on the other side. So here's what we have. We're going to have 1 over 7 plus 9y dy equals to 6 plus 7x times dx. Okay, now what's left is you just have to integrate both sides. So let's do the integral. Actually, let me just put the integral sign right here. So you integrate this left side, you integrate the right side. And for the left side, what you want to do is, this is like f prime over f type, so make sure you remember that the integral of f prime divided by f, not there, but if you integrate this, it's the ln of the denominator. So I'm using this fact, except that, if you differentiate 7 plus 9y, 7 becomes 0 and 9y becomes 9. So you really need a 9 there, but we only have 1. So what happens then? Well, what you do is you put a 9 here and you put a 1 over 9th in front, so that this indeed looks like f prime over f. And if you do that, then the left side will be, you're going to get 1 over 9 times ln of 7 plus 9y equal to, and on the right side you have 6 plus 7x. So if you integrate 6, you get 6x. And then if you integrate 7x, you get 7 over 2 x squared. And then when you integrate both sides, you have to put plus c, but you should put plus c only on one side. Don't put it on both sides. So we're almost done. Oh, but wait, we decided to call the constant as k, not c. So we're just going to put this as k. And then in order to put this into this format, I guess this is a function of x, so that should go to the left side. And let's see what that gives us. It's going to give us negative 6x minus 7 over 2 x squared plus 1/9 ln of 7 plus 9y equal to k. And that's it. That's the final answer.